Let's discuss the noise region, which is essential to calculating the signal-to-noise.
There are a number of signal-to-noise calculations, and we visually identify the signal and noise regions. So the signal can be, of course, the primary or an alternative integrated peak. The noise region is shown, and there are a number of choices in the method editor as to how to calculate the signal-to-noise ratio.
So I'll show you in the demo in a moment how to set up the properties, but you can change the color so it delineates what is identified as noise. In this case, I've colored it gray. You can see that on the edges of the peak it will include that in part of the noise, and basically that noise is used as the denominator in the signal-to-noise calculation. Alright, for the demo, here I am in Batch at a Glance looking at some samples on a compound MEK, and I'm going to go to the graphical properties, and I'm going to turn on the noise region, and I will turn it gray. I have a choice of colors here, and I'll apply that, and you now can see that all of the noise is identified with the color gray, and those time zones, time ranges, are colored gray. And as we go through the samples here, we can see that it picks up that noise region and funnels that noise into the signal-to-noise calculation. Alright, here we are for the noise region demo. I'm in Batch at a Glance looking at some samples, and you can see I've added the columns for noise. That's the noise calculation, which then funnels into the signal-to-noise calculation. How the signal-to-noise is calculated is set up in the method editor. There are a number of choices. So to see the noise regions, I need to edit the properties for this graphics. So I'm going to go here to the noise region, and I have my choices of different colors. I am going to just choose gray and apply. And now I see that the noise regions have turned that color gray. So if we step through the samples, you can see that those regions are identified. Thanks for your attention.